pressure are you talking about to push it back down? You said that, take out a lot of the impurities or whatever, I mean, and so you don't have to have the pressure. What pressure are you talking about?
Yeah, so on the inlet side of this, we only raised the pressure by a small amount, about 50 to 100 millibar over the ambient pressure or normal air pressure. So that's, on the order of like 1 psi. So it's a very low pressure that goes in. And then on the vacuum side, we pull out, like I said, about 80% or so of the pressure. It's actually less here because you're at relatively high elevation. So the atmospheric pressure is not quite as high as it would be at sea level. And so I should say these are kind of absolute pressures. So we would use the same pressure on the regeneration in Denver or like Seattle on the ocean. So that wouldn't change.
Where are these vessels made?
For this project, we don't know yet for sure, but there's a good chance we'll be looking at some local places, in most likely Gillette, Casper, somewhere in this particular area. But that's a little ways down the road. Yes, we can't say for sure, but those are some of the places we're looking at.
And if you have a recommendation, be sure to let us know.
Yeah,
Anywhere in Gillette would be great.
That sort of material,
Mhm.
so it's like activated carbon.
Mhm.
Is coal the source of that carbon?
No, so for that, we use mostly biological materials, and so it's mostly sugars, cellulosic materials, cornstarch, those kind of things. So it's mostly bioproducts that go into the soil itself.
The schedule that you've presented so far is 6 years. Was that created before this election?
Yeah, so the original, just to give you an idea, the original proposal on this would have gone in the summer of 23. And then the award selection for this came out in November or so of 24, some announcements around like February 24. And then it took about 6.5, 7 months of negotiations before the contract actually went into effect in August of this year. And that's pretty typical actually of the pace of things within the federal system.
What's the final product? What do you do with the CO2? I mean,
Yeah.
you put it in consumption.
Yeah, it's a great question. So for this particular project, that's a little bit up in the air still. Officially, one of our goals of the project, or our intention, if you will, is that we would like to do carbon capture the right way and do sequestration. And OSED at the Department of Energy, they would like to see that happen as well too. There are some definite challenges associated with it, and they're primarily on the finance and accounting side of things. Without getting too deep into it, basically, there's a thing called 45Q, which is a tax credit for carbon capture. It applies both for industrial point source capture, which is what this is basically capturing CO2 at the point of use. It also applies to like direct air capture, where you're pulling CO2 out of the air, sometimes called carbon dioxide removal. But the way that those credits are currently structured, the rules of which are partially set by the IRS, which may seem kind of weird, but it's a tax credit, so that's why that's the case. For a power plant, which Dry Fork Station is, you have to capture 75% of the CO2 in order to apply for the credits. So since we're only doing about 5 or 6% of the stream, we can't apply for the credits. There are some other interesting aspects to the law too, and I'm not a tax attorney or a tax expert, so I won't get into this too deeply, but in a nutshell, the way the credits are structured, once you start taking those credits for a given source, whether that's like Dry Fork or a cement plant in Billings, Montana, you can basically claim those credits for 12 years. So even if we wanted to start pulling credits, or Dry Fork wanted to start pulling credits and doing that right away, they wouldn't necessarily want to do it because it would eat into their 12-year window where they can do that. So we're not sure yet exactly what all the possibilities are going to be, and since it is about 5 or 6 years down the road before we're actually going to be capturing the CO2, there's some chances that some of this might change. These kind of rules do change from time to time, so I can't tell you today exactly where that's going to go. But based upon the current rules today, the most likely scenario is that we'll end up actually releasing this CO2. But eventually, there probably will be, or at least based on current laws, and EPA regulations, there will probably be capture at Dry Fork Station, and there is a plan and already a project called Wyoming Carbon Safe I don't have anything to do with them, so I can't represent them at all. But they've already been looking into and drilling and preparing to do carbon capture and sequestration around the plant. And they have injection wells just a couple of miles from Dry Fork.
So you're saying this project, basically, you're gonna pull the CO2 out of the flue gas and then release it back into the atmosphere?
Good chance of that, yes. I can't say definitively, but most likely that's what's gonna happen with this project, yeah. And I agree with you, it doesn't necessarily make a lot of sense, but that's been the state of almost every carbon capture demonstration to date. That's pretty typical.
On your 6-year schedule, when is that unit going to be operational out here in the plan?
So it'll be just in the kind of last like 2 years, so about 4 years from now.
What goes on between now and then?
So we've got about another 16 months or so left of essentially engineering design work. And then we've got about a year after that wraps up, which will be permitting and making sure all the finances are secured in order to run the project, which includes the cost share aspect, which is about 30% of the total cost that us and the partners will bear. And then during that, some advanced procurement, some of the equipment has very long lead times, as you might imagine for this. And then we go into construction. And currently we're looking at approximately 2 years for construction and shakedown. So that'll include building like these large vessels, moving everything that can't be built on the site into the site, installing it, the equipment for some gas handling, vacuum, so on and so forth, bringing all that stuff together and then turning it on and making sure it's actually functional.
So a year and a half or so of design, is there a good chance the final product will look very different than that?
Probably not very different, but it won't look exactly like that. Won't be as shiny for sure. But no, we're expecting it to look fairly similar to this. The main thing that'll happen in this next bit of design phase is really kind of optimizing all of this piping and layout that you see kind of in the bottom. We have a pretty good idea on what the actual contactor vessels are going to look like. So a big part of that will also be taking a look at how it fits into the available square footage at Dry Fork, as opposed to just a generic site, which this one's kind of based on.
Will there be any significant downturn in energy produced at the plant as a
That's a
result?
great question. No, we will use some of it to power this, but no, for this particular demonstration, it won't have any impact on the plant itself. So it's a nominally 405 megawatt plant. It'll still be a 405 megawatt plant. We're just probably gonna buy some power from them.
And how much power will you need to buy, do you estimate?
I don't have the exact number on that, but yeah, it's not massive. I mean, it's not going to have a significant impact on like the power that they're available to sell.
So if it's $70 million for 6%, like if you were to capture 100%, you're talking over $1 billion, which I know it's not adjusted for inflation, but that's the price it costs to put the entire power plant. So there's no way this is gonna make the power plant cost competitive against natural gas or even wind and solar. So it seems like we're just making a way to make it less cost effective. The end.
Yeah, I mean, so carbon capture is not in and of itself going to improve the efficiency of plants, and it's not on its own going to drive down cost. The goal in general, and part of where the like 45Q credit values are kind of set at, right now it's $85 per metric ton of CO2 captured, although it kind of depends on where you stick it. So that's for sequestered CO2. If you do things like enhanced oil recovery, you don't get as much of a credit back on that. If you use it for other utilization purposes, I think you get the full $85 per metric ton. The goal, overarching goal of CCS and DOE in general is to drive that cost of capture down to where it's lower than the credit value or no higher than the credit value, so that ends up being basically a push. So that, yes, there would be some additional costs, but you recoup most of that through the credits. I don't have a final TEA on this, so I can't give you the exact number on that, but that's the goal that we're looking at too. And in general, I think in most cases, that's where you're gonna see commercial deployment, is where the financials make sense. Yeah, I mean, and the point of this project is to basically take this kind of absorbent technology, and we're among the most advanced absorbent technology providers for carbon capture systems available right now, and get it closer to a maturity level where it can see that full scale commercial deployment. Right now, there's really only kind of one technology that's at commercially deployable and mature, and that's basically like an amine scrubber tower, liquid sorbents. But there are other technologies like this solid state sorbents that we're developing, membranes, and a variety of other things, which are just not quite as mature yet. So one part of what DOE is interested in with projects like this is to have more options on the table, get some more of those things to a point where they're mature enough that they could, really be considered for commercial scale. One thing I would point out, was planning to talk about it a little later, but this is a totally fine time to mention it. While this system is only good for about, like I said, 5 or 6% of the flue gas coming out of the dry fork station, it is large enough to be a commercial scale plant for other places and other sources. So we do hope to be able to basically disassemble this and relocate it to a place where it can capture the full stream and become a commercial unit with sequestration down the road. So it may not, if we're not able to make everything work, it may not actually permanently store any CO2 in this installation, but we hope that it will be permanently storing CO2 somewhere in the future. And then something can do that here. Not this system, maybe with bigger butted bars or maybe somebody else. Yeah. Oh, sorry, I'm done. Gonna move on. Thank you. So talked a little bit about some of these things already, but to give you a little bit more background kind of about the sorbent. One thing that we're excited about with our solid state sorbents, which is not necessarily true with every competing technology, especially some of the liquid adsorbents, is that our material pulls CO2 out. It doesn't give off anything else. The basic mesoporous carbon won't release other potentially toxic gases to the environment. It's basically pretty benign stuff. The only thing that can really happen, and part of the design on our bed is to make sure that this doesn't happen, is it can kind of render into fine dust and release basically some carbon dust. But other than that, it's really nice in that regard. Similar kinds of sorbents are used for drinking water applications like granulated activated carbons, like we talked about. This particular sorbent has been, demonstrated to show no degradation over tens of thousands of hours in the field. So we think, a realistic service lifetime is more than 3 years before we have to do a sorbent change out. So it lasts a very long time. And like I said, when it's done, it can basically be disposed of in landfill type applications. So it doesn't require special handling. On the transport side, it's not classified as a hazardous material, so it can be basically transported in any number of ways, rail cars, you name it. It's pretty easy to transport. From a handling perspective, basically the same kind of personal protective equipment that you would recommend for most things. Wear some gloves, probably like an N95 mask, so that you're not inhaling any dust if you're handling a bunch of the stuff. But other than that, doesn't require anything super special. It's not a volatile, it's not explosive, it isn't corrosive. If you get it really, really hot, it can combust, but it has to be well above like 600-700 degrees Fahrenheit before that's a concern. And then from a hazard standpoint, it doesn't currently have any, exposure controls or limits, and it's not, an environmentally hazardous substance. So it's pretty safe stuff. Like I said, it's basically made out of biomaterials like sugars, starches, cellulosic stuff. So it's pretty straightforward.
So
Yeah.
with this particular plant on a 3-year change out, how many tons are we talking about?
It's quite a few. I don't have the exact numbers, but I want to say it's on the order of like 10 tons per bed it's in that range. Yeah, so it's pretty good size.
The original number you were using is 158,000 tons. Is that in a year, in a lifetime?
That would be that would be the average CO2 removal for this particular demonstration over a year. So if we ran nonstop for 365 days, we should remove about 158,000 tons. Ballpark.
And what's the ton of that look like? What? You're not talking 2,000 pounds, are you? Or is it?
Yeah, it's 1,000 kilograms. So about 2,200 pounds.
So, to think about a semi
tanker. We see them going down the road, they're 24 tons. There's one semi truckload of liquid CO2, that gas, it expands about, well, 17,000 cubic feet per ton.
Yeah.
So,
Yeah.
but 10 ton per bed of sorbent change out in 3 years.
Yeah, kind of
approximately.
yeah.
Right.